Hello everyone, my name is Felix Schuster. I'm the CEO and co-founder of Edgeless Systems. We are a company based in Germany building open source software for confidential computing, specifically infrastructure software and SDKs. And we are doing this in the open. So most of the things, or all of the things I'm going to talk about today, can be found on GitHub. And we have been doing this since 2019. By now we are roughly 20 people, based in Berlin and a place called Bochum. My talk today is about how to wrap entire Kubernetes, how and why to wrap entire Kubernetes clusters into confidential computing. Now the first question is, why would you want to do this? And well, it took some time for us to realize that this is the way to go. And when we started in 2019, we initially started with an SDK for Intel SGX called Ego. And as the name suggests, Ego is about running Go applications inside Intel SGX. And it's a great tool. It's still on GitHub, and there are a couple of users out there. But what we kept hearing from companies and institutions is, okay, look, we love this confidential computing thing. We are no experts in SGX, no experts in Go. Can you please just make this application over here, this cluster over here, somehow magically confidential? And we kept hearing that. And in many cases, people had, well, Kubernetes clusters, containers. And so we started building what the customers were asking, a simple solution to take existing deployments, existing applications, and just make them magically confidential. That is the why. And now let's talk about the how. Of course, maybe a simple solution would be, okay, we just now run containers in some form of confidential environment, right? Inside an SGX enclave, inside a confidential VM. And maybe this could be good enough in some scenarios, but most of the time, you won't really be protecting your entire application end to end. And here's a quick illustration of that. Let's say we put container A and container B into a confidential VM. Then these containers are protected, right? But if container A wants to talk to container B, then container A would need to verify the integrity of container B using remote attestation, and container B would need to do the reverse thing, and then they would need to exchange a key, and then they could talk securely to each other. And well, once we have done that, other questions will arise, like how will we persist data to storage? How will we protect our interface to the control plane? And what happens if we scale this up and down, if we add new containers? A ton of questions, and it's really more complicated than it may seem on the surface. So just putting containers into confidential computing environments doesn't really solve it. What we want to have instead is something that is end-to-end, where our entire distributed application, all of the containers are protected. Everyone knows who everyone else is. Container A knows that container B is good and so forth. And if one of them writes to storage, we want that to be encrypted automatically. And we don't really want to deal with the key management for that. So we really want to have very free confidential computing that is scalable and end-to-end and doesn't end at container boundaries. Okay, how do we get there? There are a couple of approaches, 3 approaches. Approach 1 is the first approach we followed. And this is about Intel SGX. So consider a Kubernetes node, for example, on Azure, on AKS. AKS has SGX-enabled nodes. You will have some pods, you will have some containers, you will have a kubelet, all on one node, and then you maybe have many nodes. And you, of course, have a control plane. that is, in that case, maybe managed by Azure or some other cloud provider, or could be managed by yourself. Now, there will be other nodes, and yeah. Now, inside one of these pods, we can now launch an SGX enclave and protect parts of that container against the rest of the world, against the other parts of the container, the pod, the overall node, and against the control plane. This is how it works on AKS with Intel SGX, for example. Now, what we want to have is, as I showed in the previous picture, we don't want to have a single node, a single secure environment. We want to have a cluster of secure environments. So we want to have maybe many nodes with many SGX enclaves, and we want them to talk securely to each other. And here, we want to keep the control plane outside the trusted computing base. We don't want to have to trust it. Right, there are all these threats, and we don't want to, well, if the control plane is compromised, we don't want to have to worry about that. And this is what our Marble project does. So Marble is focused on SGX and Kubernetes, and Marble takes care of all of the boilerplate tasks that arise if you have a cluster of SGX enclaves and you want to have them talk securely to each other, if you want to share secrets between them, and if you want to attest and verify the semantics and integrity of your cluster as a whole from the outside. So it's really taking care of all of the boilerplate tasks, and you can think of Marble as a service mesh for confidential computing. Marble is a service that you install on your Kubernetes. Marble itself runs inside SGX enclaves. And you give Marble what we call a manifest. The manifest defines precisely what can happen in your cluster, what types of enclaves are allowed to run in your cluster, what type of secrets exist in your cluster. And then whenever a new enclave comes up in your cluster, it will automatically talk to the Marble service. Marble will engage in remote attestation, will verify the enclave according to the manifest, and will then hand over secrets to the enclave, which will let the enclave automatically talk securely to other enclaves, which have been verified before according to the manifest. And now if someone from the outside comes, let's say this is a web application, and there comes a user, let's say it's a web application for a secure LLM app. Now, if a user comes now with a browser, you can talk to Marble and you can get a remote attestation statement which includes the manifest of the cluster and from which you can infer that the entire cluster adheres to the manifest because everything in the cluster has been verified by Marble, and this is what you can learn from the Marble remote attestation statement. Yeah, so this was our first step at getting to a confidential Kubernetes. You can find this on GitHub, and we're currently working on extending Marble to not only work with Intel SGX, but to also work with Cocoa. And this brings me to approach number 2. This time, it's not about protecting parts of containers. This time, it's about protecting entire pods or containers using the Cocoa Confidential Containers project, which is now a CNCF project and gets contributions from a wide range of companies. The problem with Cocoa and a cluster-wide protection of your deployment is that you still have the kubelet outside of your trusted computing base, and the kubelet has a lot of control over your pod. And I know that Microsoft and others are currently working on protecting the pod against the kubelet, but until this problem is solved, it will be quite difficult to really get end-to-end confidentiality for your entire cluster. We are also working on this, and we're trying to bring Marble to this approach number 2, which will then also, well, not only support SGX, but TDX and SEV. But for now, it remains unsolved. So let's move on to approach number 3. Approach number 3 is not at the container level, not at the pod level, but on the node level. This is what we are focusing on, we as a company are focusing on right now. It is protecting all of the worker nodes in Kubernetes and all of the control plane using confidential VMs. And this way, we sidestep the problem of the kubelet having control but not being trustworthy, for instance. And yeah, we just wrap everything. We just wrap everything into confidential VMs, and then we use similar concepts as I described for Marlboro previously to verify all of the nodes, setting up secure connections, enforcing policies and so forth. And then we have, well, let me get back. And then we have a cluster of nodes that is running containers, that is shielded as a whole against the infrastructure, where everything is talking to each other over secure attested connections. And if you write to cloud storage or if you write to local storage, we also take care that everything is encrypted. So it is a worry-free Kubernetes cluster where all of your data remains always encrypted. And one second. Yeah. Just checking it's a correct slide. Everything remains always encrypted and everything is attested at all times. So how does it work? Well, Constellation consists of a couple of key components. The first one is the CLI, the command line interface. The second one is optimized node images. The next one is in-cluster services for attestation. So we have all the nodes run our custom optimized node images, read-only node images, which are optimized for remote attestation. And once we bring up a node, we bring up a cluster, we then run our services inside the cluster itself, and these services take care of verifying new nodes, managing keys, and talking to the outside world and so forth. Oops, sorry. Another key component is transparent encryption of storage and network. And we have reproducible builds. So this is really a key component that we have, and we feel that this is really key for attestation in general, having reproducible builds, so people can really see what I'm running here is the intended software. And we actually use SigStore to publish the measurements of our measurements and signatures of our builds. So here's the CLI. And it's easy to use. So if you want to set up a Constellation cluster in Azure, Google, or AWS, it's essentially a couple of commands. So you download the CLI from GitHub. You log into your cloud subscription. You type in Constellation create. This will then talk to the cloud provider's API, bring up your first VMs. We will automatically boot our small optimized node images inside these VMs. The CLI will then verify the integrity of the first node, and then the cluster will essentially verify itself, and that's it. And then you already have a secure connection. We give you back a Kubernetes config, a kube config, which you can add to your kubectl or any other Kubernetes front-end tooling, and this will automatically give you a secure, attested connection to your cluster, and you can then you can essentially install any Kubernetes compatible application and have peace of mind and know that this is shielded against infrastructure. And it's all on GitHub, and you can try it out at c11n.sh. And yeah, download the CLI and get started. You should be able to get your first cluster, your first end-to-end application running in maybe under an hour. Okay, quick look at how this works. Cluster initialization. The CLI, the DevOps engineer, the CLI running on the side of the DevOps engineer engages in a TLS connection, a tested TLS connection with the first node. They verify each other, well, the CLI verifies the node, and then there is an init call, and yeah, we get the kube config back, and the kube config has all of the information that's required to set up the secure connection. Next is a quick sketch of the protocol if a new node wants to join, right? So it could be that well, we have failover or we want to scale the cluster. In that case, the new node talks to a service running inside the cluster that has a policy for verifying new nodes. And it's pretty similar again. We have an ATLS connection being set up. The service running inside the cluster verifies a new node based on the given policy. And then the new node gets a token to join the cluster, gets the keys to talk to the other nodes, and then, yeah, it is part of the cluster. If you're interested in a case study, so there is a case study we did with an organization called OCCRP. They are investigative journalists. They, for example, published the Panama Papers, the Swiss credit leaks. They have very sensitive data, and they recently migrated from GKE on Google to Constellation to protect their highly sensitive data. And we will soon publish this on our website. And if you want to have early access, please feel free to shoot me a mail. That's it. Thank you very much. And yeah, maybe there's time for one question. Yeah.
What's the difference with other cloud providers, Kubernetes solution with virtual computing?
Yeah. So the big difference is remoteization. What I had in the beginning, you currently on the managed Kubernetes you only get single container, single node protection with no specific attestation. So there are gaps, and of course you can work around that, but we've already figured that out. So you may as well just use our software. Cool. Thanks.